Hello, welcome. Episode 16 of the tutorial on mechanics. In just ended episode, which is episode 15, we deal with how we can resolve forces from the magnitude direction form to either the vector column form or the Cartesian coordinate form. We are taking the reverse of that, expressing forces from the component, which is the vector component form, to the magnitude and bearing, which is the same as magnitude and what? The distance form. Now, what are we looking for? We are looking for the magnitude, the size of that forces, and we are also looking for the direction of that forces. So, if, for example, we have a force which is given in the form xy, this is the force which is given in the component form, which is xy component. Then its magnitude, we can just say that its magnitude is defined as the magnitude of the force equals to the square root of the x component square plus what? Y component square. That's the magnitude. So any force that is in the xy vector component form, if you are looking for the magnitude, it is the square root of the square of the first term, which is the component for the x, basically the horizontal axis, then the y, which is what? The vertical axis. That's the first thing. So first thing to do is to find the magnitude. Then for the bearing, or better still, we can say that for the direction, what are we going to do? We find the acute angle, the angle that the xy will make with the x-axis. That angle is what we are going to be looking for. And that means that if I am looking for that angle, that acute angle will be equals to the tan inverse of y over what? X, regardless of the sign, whether it is negative or positive. You pick only the absolute value of that. So let's see if the angle is in the first quadrant. If the angle in the first quadrant, remember, vector and forces are moving in the clockwise direction. So we are measuring from the north. Then we measure. So we are having a particular force. Can I use force 1? This is showing the magnitude. Remember, the angle with the x-axis is going to be here. This is the angle with the x-axis. So if I know this very angle in the x-axis, which is going to be facing here opposite the y component, divided by the adjacent, the x component, that is why I are seeing that. Then it means that if I am looking for the bearing I am looking for this force, for moving from north to this place, knowing this angle will just be from north to the x-axis 90. So it is just 90 degree minus what? Theta. If I subtract the angle I have with the x-axis from 90 degrees, then I know the bearing of the force measuring from the north. Then if I take the second quadrant, so let's see, we are taking the second quadrant. We are going to move 1, 2. So I am going to be here with my force being force 2, or a different force that I am having in that quadrant. Remember, we are looking for the angle the force make with the x-axis. This is the x-axis. So the angle we are looking for is here. So the moment I find this angle, remember it is facing here as the opposite, picking the vertical axis as what? Y, over the adjacent, which is what? The x component. So still y over x, the tan inverse of that. Now, knowing this is not the bearing of the force. The bearing of the force is the measurement from the north direction all the way to where the force is. So all the way from here to here. And that gave you 90 degrees plus what? Theta. Knowing the magnitude. After finding the magnitude, the next thing is knowing the angle. And we need to find the position of the angle that makes it the x-axis. We find that we add it to 90. to get the actual bearing of the force from the north. I guess that is clear. Let's see if you are taking the third quadrant. So in the third quadrant, we have first, second, third. The third quadrant, we are having the angle, the force, which is the force 3, make with the x-axis, this angle. So if I know this angle, what do I do? To find the bearing is from the north all the way to where the force is. So it means that if the force were to be here, that would be 270. It is not up to 270, meaning it is less than what? 270. You subtract that angle from it. So for the third quadrant, you subtract the angle, the acute angle you make with the x-axis from 270. Then for the fourth quadrant, let's say we have this. The fourth quadrant is going to be here. We have the angle here. The force is going to be here, force 4. And this is your north. Your measurement is still from north all the way to the force. So we move from here, we come here. That is the direction of the force. The force is measured for the north. Then that means that if we're to be here, 270, we have an additional value before we get to what? 360 or 0. So that means that your angle will be 270 plus what? Theta. So you can see that the direction is either 90 plus or minus theta or 270 plus or minus theta, depending on the quadrant. So the quadrant will either determine whether it will be plus the 90 or minus the 90, or plus the 270 or plus what? The 270. All right. Now, all these will make sense if we pick real examples to test this hypothesis. So let's see if we are given some forces in the vector component form, how we can resolve them into the magnitude and bearing form. Okay, so let's see, we are given this force. Let me say this is a force 1, which is in the component form as 3-4 Newton. So converting this into the magnitude bearing form, first thing we need to do is to find what? The magnitude, right? So this implies that the magnitude of the force 1 equals to the square root of 3 squared plus what? 4 squared. And if we can do this, I should have 9 plus 16 equals to root 25 equals to what? Let's just put it here. 5 what? Newton. So the magnitude is what? 5 Newton. Then to get your bearing, remember 3 is positive for x, so I should be here. Then 4 is positive for x also, so 4 is here and 3 is here. So if the force ended here, our force is going to pass here as 5 Newton. We need this angle here. So if I join this point down, making 90 degrees, the distance here is going to be 4, and the distance here is going to be 3. So we know that the angle there is to be tan theta equals to 4 divided by what? 3, which make our theta equals to the tan inverse of what? 4 over 3, and we can check that on our calculator. So that will be giving us 53 approximately as a whole number. But remember, in the first quadrant, the bearing of the force measured for the north is north, which is from here all the way to this place, not up to 90. Therefore, that make it 90 minus what? 53 degree, and that will give us what? Let's check that on our calculator. That will be giving you 37 what? Degree. So therefore, your force that we are going to have in the, let's use the F1 as we are having. F1 force is going to be, the magnitude will be 5 Newton. The direction will be 0 what? 37 degrees. So this is the first one, right away from the vector component form to the bearing distance, magnitude what? Bearing form. You can see this is how we describe forces from the very first episode. All right, let's see if we move to the second quadrant, giving force 2, which is going to be, let's say I have the root of 3 and -1 Newton, something like this. Let's see our magnitude of force 2 equals to the root of 3 all square plus -1 all square. The first x component square. If you square that, we have only 3. So we have 3, -1 square is what? 1. So that gives us the root of 4 equals what? 2 Newton. Now, fast forward, let's check the direction. The value for x is positive, so I should be having my root of 3 here as the positive x value. The value for y is what? Negative, so I am going down here as -1. So their intersection, the force is here, the angle it makes with the x-axis, bring it down there. So this is going to be your 90 degrees. What do we do? The distance here is the measurement from the origin to the -1, which is 1. The distance from the origin to here is the root of what? 3. So what do? We just have opposite over adjacent to find the angle theta. So from here, we can say that the tan theta equals to the opposite side, which is 1, divided by the hypotenuse, which is 3. So fast forward, theta will be equals to the tan inverse of 1 on what? Root 3. Let's check that on the calculator and see. That gives us our theta should be equals to what? 30 degrees. Remember, in the second quadrant, what we have, it is from the north. So you can see that the bearing of the force measured from the north is going to be your 90 degrees, which is here, plus that angle we have there, which is what? Angle 30 degrees. And that will give you what? 120 degrees. So we can say that, therefore, the force 2 in the magnitude, which is 2 Newton, and bearing form will be 120. So this is when we have forces. Don't forget, this could also be given in the Cartesian coordinate form, as in the root 3I minus j, which is still the same in this form. Then you translate and come back to where we are successfully. So let's see, we have number 3. So if we are given this as the force in the vector column, the magnitude will just be the root of -1 square plus -1 square. Remember, if you square a negative number, you get a positive value, plus that will give you the root of 2 Newton. So we can leave it in this form or find that in decimal as what? Root 2, which will give you 1.4 what? Newton. What do I need? I need to find the bearing of that. So for the bearing, let's pick this. Remember, we are having negative x-axis, negative y-axis. So we have our -1 here and -1 here. So their center will be here. The angle with the x-axis, which is the acute angle, make this distance of 1, distance of 1. So we can say that tan theta equals to 1 over 1, which is 1. So theta will be equals to tan inverse of just 1, because 1 over 1 is going to be 1. And that will give you theta equals to what? 45 degrees. We are in the third quadrant. So we have 90, 90, this angle, or the whole of this is supposed to be 270. So we subtract the 45 from it. So the bearing that we are going to have measuring for the north is going to be 270 minus what? 45 degree. And that will be giving you, I think, 225. If you put 2 here, 16, so 225 what? Degree. So therefore, the force 3 that is in the bearing distance, that is in the magnitude and what? Bearing form is going to be the magnitude 1.4 Newton, distance or bearing is going to be 225 degree. The distance will be a direction, not a distance. All right. So this is also showing the force resolved from component form in the third quadrant to the magnitude and what? Bearing form. All right. Let's see the last aspect. Okay. So if we have this, fast forward, let's find the magnitude of the force 4, which will be the root of -3 all square 4 squared. I should be having the root of 9 plus 16 equals to root 25 equals to 5 what? Newton. So our magnitude is going to be 5 Newton. Let's find the bearing. So for the bearing, we have our Cartesian plane. Don't forget we can label the north and have our x-axis. So we are having here to be the same y-axis, negative for x. So I'll be on this place, -3, positive for y. So the point will be here. Angle with the x-axis to be here. Then that form our right angle triangle. The distance here is just 3, not a -3, and 4. So I can say that the tan of what? Theta will be equals to the opposite over the adjacent. Then fast forward, I can have my tan, no, let's go for the angle direct, equals to the tan inverse of 4 over what? 3. And what would that give us? I think in the first example, it gave us 53. Yeah, that is 53 degree. It will need a whole number. So our bearing. So from if the bearing of the force measured from the north all the way from here to meet this line, it will be 270 degree plus what? The angle we found with the 53 degree. And that should be giving you 300 and something. And that will be 323 degree. So therefore, the resolution of the force 4 is going to be the magnitude we had was 5 Newton. The direction we have was what? 323 degree. Now, if we check all that, the examples that we have done, we have taken all the aspects, all the quadrants, 1, 2, 3, 4, where the value alternates from 90 plus or minus theta or 270 plus or minus what? Theta. I did mention that when we are giving the force also in the Cartesian coordinate form, the same procedure is followed. As in this could be, this is this thing. It could be -3i plus what? 4j. This is what will be given to you in terms of what? Newton. And this is the x component, the horizontal component. This is the y component, the vertical component. So you only see this in this form, then you follow the same procedure, you get to the same place. I guess the concept is clear. Like the video, subscribe if you have not, leave a comment, and bye-bye.